tangents and secants. Let's draw up a circle. And just so we can see what tangents and secants actually are. So a tangent is just a line drawn on the outside of a circle that only touches the circle once. So here, this line touches that circle only once, and that becomes a tangent. And a line that goes through the circle and cuts it twice, we call a secant. So this line here is a secant. And there are a few different properties we can look at with tangents and secants, which we're going to look at now. So let's draw up another circle. Let's draw up a circle. Now, our first one is two tangents drawn to an external point are going to be equal in length. So let's put an external point out here. And if we draw two tangents going to that external point, let's draw one like there, so that tangent is only just touching it once. So if we continued it out, it wouldn't touch it again. And another one, which looks like about there, if we continued that out, it wouldn't touch it again. And those two tangents will be equal in length. And also, if we if we drew a line from where the point of contact is on the tangent to the center, so making a radius with both of them, we get 90-degree angles at the radius and the tangent, and that's another property of a tangent. Let's draw in another tangent for this circle, so a line that only touches the circle once. And let's draw a few other lines in. Okay, so this one's called the alternate segment theorem. And the theorem is that the angle between a tangent and a chord drawn to the point of contact is equal to the angle at the circumference in the alternate segment. So let's break that down slowly. So it says the angle between a tangent and a chord. So here we have an angle between a tangent and a chord. Let's call it A. So there, an angle between a tangent and a chord drawn to the point of contact is equal to the angle at the circumference in the alternate segment. So here the alternate segment is the one opposite over here. So this angle here is also equal to A. And we can do the same thing over here. If this angle equals B, the one in the alternate segment is over here, so this angle there also equals B. Okay. This time let's draw two secants going to an external point. So we have some external point here, and we've got two secants that we've drawn in. So let's call this A, B, C, D, and the external point P, where these are the points on the circumference where the secant goes through. Now, if we have this, we can say that AP multiplied by BP equals DP multiplied by CP. So AP multiplied by BP, the whole length, so the bit that comes out multiplied by the whole length equals, in the other secant, the bit that comes out multiplied by the whole length. So when two secants intersect at an external point, the products of the intercepts are equal. Let's look at one more. So now we're going to draw a secant and a tangent. So here's our tangent. If we continue to only touch it once, and let's draw a secant in. Let's call this A, B, C, and the external point we'll call P. So this is where it's contacting the circumference. The external point P is out here. So if we have this, we can say that when a secant intersects a tangent at an external point, the square of the tangent to the circle equals the product of the intercepts of any secant from the point. And a mathematical way to write that is this, that CP squared is going to equal AP times BP. So it's the length of the tangent to the external point squared equals the bit coming out of the secant AP multiplied by the whole secant BP.